In this video, we'll look at the effect of switching costs. As the name suggests, switching costs are just the costs of switching from one firm to another. So for example, with banks, it can sometimes be costly to switch from one bank to another because you have to fill in forms, shift over your direct debits, tell your employer your bank account has changed. So all of these create switching costs. So to see what effect switching costs have, we're going to take the standard Bertrand model and assume that there are two periods. In the first period, which we're not going to model, consumers are split equally between firms A and B. And if a consumer goes to a new firm in period 2, they incur a switching cost S. To keep things simple, we're going to assume a continuum of consumers of mass 1. So there's a total of one consumer. And each consumer is willing to pay up to V, so the monopoly price is V. So this model should be familiar as it's the same as the model we use in the pricing game with shopping costs, except we have two firms here instead of three. So what we're going to show is that for any switching cost S bigger than 0, there's no pure strategy Nash equilibrium where a firm prices below the monopoly price. So that's the first thing we're going to show. So the proof here, well, we just need to show that for any pair of prices where one firm is pricing below the monopoly price, then the firm with the lower price has a profitable deviation. So let's suppose that firm A is pricing at a level less or equal to firm B, and firm A is pricing below the monopoly price. Then firm A must have at least half the consumers because they are the lower priced firm. And so if A raises her price by less than the switching cost, she will not lose any consumers and her profits will rise. So a switching cost means that for a firm who is pricing below the other firm, raising their price will not lose them any customers because they'll only switch if this firm's price is above the other firm's price by more than the switching cost. And so raising the price is going to increase profits. So what is the Nash equilibrium? Well, as long as the switching costs are sufficiently large, then there's a unique Nash equilibrium where the two firms price at the monopoly level, V. If each firm prices at the monopoly level V, then their profit is going to be half times V minus C, where C is the marginal cost. Each firm is getting half the demand. So to show this is a Nash equilibrium, we need to show there are no profitable deviations. So let's look at the possible deviations. Let's suppose A raises her price. Then she'll get 0 demand because now her price is above V, which is the most anyone is willing to pay. What about if A lowers her price? Well, in order to attract any of B's customers, she must choose a price that is less than B's price by more than the switching cost. So A's price must be less than B's price, which is V, minus the switching cost. And with a price like this, A will get all of the demand. The demand will be 1. Is this deviation profitable? Well, let's write down the condition for it not to be profitable. So if A deviates and prices at just below V minus S, then her profit is going to be 1, her demand, times V minus S minus C. Well, in fact, her profit will be a little bit less than this because her price is a little bit less than V minus S. Now, when is this quantity less than or equal to A's profit when she prices at V? Well, we look at the profit she gets when she prices at V and see when is that larger. So when is the profit from pricing at V greater than or equal to the profit from pricing at something slightly less than V minus S. So let's rearrange this inequality. So we have a 1 times V minus C over here, and we have a half times V minus C over here. So let's subtract half V minus C from both sides and add S to both sides. Then we end up with this inequality here. So as long as the switching cost is greater than or equal to half times V minus C, firm A is better off pricing at V than lowering a price in order to capture B's customers. So this is the condition for pricing at V to be a Nash equilibrium. So where does this half times V minus C come from? Well, when firm A lowers her price by a little bit more than the switching cost, she's going to double her demand. It's going to go from a half to 1, and this difference here represents that gain in profit. Whereas the cost is that she has to lower her price on the 1 unit she sells. To summarize, when switching costs are introduced into the Bertrand model, for any positive switching cost, it is no longer an equilibrium to price at marginal cost, because a firm can raise their price above the other firm and not lose demand. In fact, we showed that any prices below the monopoly level are not a Nash equilibrium. And we've just shown also that as long as S is sufficiently large, monopoly pricing is an equilibrium. So switching costs give firms some monopoly power. Now, in our model, we assume that each firm in period 1 had half the consumers. And in our model, we didn't say where this came from. Suppose now we model that first period. Then in period 1, firms are going to have an incentive to offer relatively low prices or discounts in order to attract an installed base of consumers. And then in the second stage, they're going to be able to raise the prices just as we showed. So what happens to profits overall? Well, they're going to get relatively low profits in the first period, but higher profits in the second period. And when you model this, switching costs actually do tend to raise profits compared to the case where there are no switching costs. So what are some implications of these results? Well, there are implications for government policy. So it is going to be worthwhile to lower switching costs in order to improve consumers' welfare. Because in our model, switching costs means that firms price at the monopoly level, consumers are getting no consumer surplus, and therefore consumers are hurt by switching costs. If we had a model with a less simple demand structure, so we had a downward sloping demand curve, then there's also a quantity effect. So if switching costs lead to pricing at the monopoly level, there's a reduction in the quantity the firms produce compared to the case without switching costs, where they produce at the competitive level. Remember, in the Bertrand model, the firms are pricing at marginal cost and producing the competitive output. So there's a place here for government policy to try and reduce switching cost. And one policy is this current account switch guarantee. So it must be easy for consumers to switch their current account from one bank to another. So the direct debits, the payment of salary, all that has to be done automatically. All the customer has to do is switch their account through, say, a website. Everything else is done by the banks.